Key features of quadratic functions. Sketch a graph of a quadratic function, and if you have the equation, what you would do is you would take c from the standard form of the equation, and that'll be your y-intercept. Then use the solutions to the quadratic equation when the equation is set equal to 0 as the x-intercept. And then the quadratic function will have a maximum point at the value of a when the equation in standard form is negative. And if a is positive, then the graph will have a minimum. To find the minimum or maximum point, you're going to take the midpoint between the x-intercepts as the x-coordinate of the max or minimum point. You could also use the equation x equals negative b over 2a, that first part of the quadratic formula. But anyways, that'll be your x-coordinate of your max or minimum. And then you plug that value into the equation to get the y-coordinate. And then an interval of increase is found by looking to see when the graph increases while x increases. And an interval of decrease is found by looking to see when the graph decreases while x increases. So we're going to go through a few examples where we'll sketch the graph, and we're going to find the x and y intercepts, the maximum or minimum, and list out the intervals of increase and decrease. So for number 1, we already know the y-intercept is negative 7. And if we want to find the x-intercepts, we would need to factor it. Now, I've already factored this, so for the sake of time, I'll just tell you that the factors are x plus 1 and 2x plus 7. To find the x-intercept, we'll set each of those equal to 0. And when we solve each of those equations, we get that x is negative 1 or x is 3.5. So here are the x-intercepts. Alright, next on our list of things to find is the maximum or minimum point. Now I know that this is going to have a minimum point because this 2 right here is positive. So to find that minimum point, I want to start by finding the axis of symmetry. Now, the axis of symmetry is going to take place right in the middle between my x-intercepts, so I could just find the midpoint of these two. But I also know another formula, and that is negative b over 2a. So negative b over 2a, that's or x equals negative b over 2a. That's a formula for the axis of symmetry. It's the first part of the quadratic formula. So if I plug the values in from my function equation here, it'll be negative 9 over 2 times 2, which gives me negative 9 over 4, which gives me, if I wanted to turn that to a decimal, negative 2.25. So that's the x-coordinate for my minimum. Now I also need the y-coordinate. So for that, I think I'll need a little bit more space. And in this space, what I'm going to do is I'm going to take my function f of x and plug in negative 2.25 for x, so I'm evaluating it. Evaluating the function when x is negative 2.25. So anytime I see an x, I plug in negative 2.25. Alright, now when I'm going to now use my calculator for a little help. Plug that into my calculator, and I get negative 3.125. So my minimum point is at negative 2.25, negative 3.125. Minimum. Alright, so let's go ahead and graph this, and then we can get the intervals of increase and decrease. So turning to the graph here. Starting off with my y-intercept, which was, I believe, 7. Yep, 7. Right here. And then after I get my x-intercept graphed, I'll go ahead and graph that was my y-intercept. Go ahead and graph my x-intercepts, and those are at negative 1 and negative 3.5. So 1, 2, 3.5 over. And then, of course, my minimum point, which would be at negative 2.25, negative 3.125. So negative 2.25, and then down 1, 2, 3, somewhere around here. Okay, and then I will try to gracefully draw a curve through these points. That's pretty close. So sketch the curve the best that you can so that fits through those points. Now we're looking at intervals of increase and decrease. Now this function starts off decreasing, then it hits its minimum, and then it begins increasing. So f of x decreases when x is less than the minimum, and the x-coordinate of our minimum is negative 2.25. And then it increases when x is greater than negative 2.25. All right, let's look at number 2. All right, for number 2, we know that the y-intercept is going to be negative 6. Oh, 0, negative 6. And I'm going to go ahead and write this in factored form. So in factored form, we have f of x equals negative 5x minus 3 and x minus 2. So we'll set this equal to 0. So 0 cannot equal negative 1. I'll set the whole thing equal to 0. 0 cannot equal negative 1. So we don't need to worry about that negative 1. We have that x equals 2 and x equals 3/5. So here are our x-intercepts. Alright, now to find the maximum point in this case, since our value of a is negative, we know we're going to have a maximum point. Could find the midpoint between these 2 points, but since we have some fractions here that we're dealing with, let's go ahead and use the formula negative b over 2a. So that would be negative 13 over 2 times negative 5. So negative 13 over negative 10, which is 1.3. So that's the x-coordinate of my maximum point. To find the y-coordinate, I just need to substitute. So I'm going to do f of 1.3. So negative 5 times 1.3 squared plus 13 times 1.3 not squared minus 6. And then I use my calculator to evaluate this. And I'll get 2.45. So 1.3, 2.45, that's my coordinate for my maximum. Alright, let's go ahead and graph this. So we're on the top graph here. So our y-intercept was at negative 6. Our x-intercepts were at 1.3. And I'm sorry, not at 1.3. That's where our maximum is. They are at 3/5 and 2. 3/5 is over here. 2 is right here. and then over 1.3 up 2.45, that's our maximum. So somewhere over here. Alright, so then we'll sketch this graph. And I think I'll try again. So this graph's a little bit better. So we can see that we have our graph that is at first increasing. So f of x increases. When x is less than that minimum, so our minimum is 1.3, and decreases when x is greater than 1.3. Alright, let's look at example 3. Alright, for number 3, we have a y-intercept at -9. If we were to factor this, we'd have that f of x equals negative x plus 3, x plus 3. If we solved this equation when it's set equal to 0, we would have x equaling -3 twice. So this is a type of function where it's only going to have one x-intercept. And so you can say that this x-intercept has a multiplicity of 2 because the factor's listed twice. So this saves us quite a bit of work actually, because since this is going to be, it's a maximum point here because we have a negative, so this is the maximum point of the graph as well as being the x-intercept. So let's go ahead and graph this. So at -3, I put a point, and then I go down to -9 for my y-intercept, and I can go ahead and sketch the graph from here. Now I know because of symmetry, I'll have a point there, so that'll help me graph it. So for this graph, this function, we have that f of x increases when x is less than -3 and decreases when x is greater than -3. Alright, so now's time to pause the video and complete the independent practice. When you are done with the independent practice, press play to check your answers. Here's number 1 from the independent practice. Number 2. And number 3.